Hi guys, welcome to our channel Math for Data Science Repository. My name is Nizar Altounji. I'm going to help you with probability and statistics. I hope you saw my previous clips about probability distributions. We have a Facebook group. You can join us guys on this name. It's a really long name, and you can get the link here. Sorry, just not working. Okay. What is this video about? Today we will learn about data, like what type of data we can work with. Um, we'll talk about descriptive statistics, like what is the measures of descriptive statistics, like central tendency, variance, shape, so on. We will work with R language, but with the base command. No, we're not going to work with the modern, like packages that are most used in these days. We will make a clip about how to work with real data, with real projects, um, with the real packages, sorry. But today we'll stick more with the academic learning. You can go really strong to applying this stuff when you have a good background about what is happening, like what is this model doing, what is the measure, how did we get to this measure, like what is the mean or something. So the goal here is to work with the base commands, and then we may work with the real packages. And once you are have a good knowledge about descriptive statistics, you can go to inferential statistics to make uh, conclusions about your population. Next videos will be working with real data and interpret results, and as I said, to work with the real packages like not base. And of course we will deal with some graphs. Okay, this thing, it's not really working. I don't know why, but okay, let me see. Nope, not working. Okay, okay. Let's begin. Data type, like what kind of data we can work with. There's a numerical and categorical. Like, of course, you can get data of photos, videos, voices, and like more complex applications. But most of the data that we usually work with are numeric and categorical. Numeric, like numbers, continuous, discrete, or it can be bind. Bind, it's going to be like categorical like here, but it's about making binds for data, like values, like data from 5 to 10 are in this group, data from 10 to 15 and so on. Continuous, like 5.5, so it's continuous values. Okay, you can as the values that continuous random variable takes, and discrete like 1, 2, 3, 4, so on. The categorical are like a nominal or ordinal. Nominal, like what is the gender, like it's a male, it's a female. Ordinal, like what is his qualifications, like he got the high school degree, he got the master degree, PhD, so on. These are some examples about data types, like continuous, like age, height, weight, so on. Discrete, like number of successes of or fails, number of purchases, like numbers of customers, the purchases that customers make, like this customer uh, uh, bought 4 for examples, pencils, so on. Bind data like age groups, like for example, 5 groups. Um, People who are uh, age between 20 to 25 are in the first group, from 25 to 30, sorry, in the other group, and so on. Nominal, it's like, as I said before, gender, city name. Ordinal, like scientific qualifications, like there is a value better than the previous one, like high school, bachelor, master's degree, PhD, so on. Like 1, 2, 3, 4, or we can talk about the grades of subjects. Like students, he may get A in math, B in physics, so on. Like A, B, C, D. Usually we enter this data in the computer as values like 1, 2, 3, 4, and you can uh, order it in the same sorry you can order it as ascendingly or descendingly, like giving one to the highest uh, value, like for example giving A for the PhD or giving 5 for the PhD, like 1, 2, 3, 4, 4, or 5, 4, 3, 2, 1. It depends how you want to enter your data and how you want to work with it. Descriptive statistics. We have three type of measures, like measures that can measure the central tendency or the variance or the shape. One, two, three. Um, like for central tendency, we have the mean, the median, the mode, percent, and cumulative percent. I will talk about them. It's really easy stuff for discrete data. Variance, like range, variance, standard deviation, quantiles, and interquartile range. Shape, skewness, and cortices. I'm not going to explain all of them in this slide. We will get into each one of them. Let's start with them. Before we start, guys, you need to know that this stuff, like, you think they are easy, and like some of you guys, they think they are useless or something. No, they are really important measures that you can uh, learn about your data from them, like what is the mean of age of the individuals of my sample, for example. um, I think most of you want to go to work like with machine learning and building models and so on, but these stuff are really I think are really they are really important, and it's a good start to work with them first, not just going to bigger applications, bigger stuff. And of course, when you work, when you get some knowledge about this stuff, you'll get another way of thinking about the machine learning, how they work, and so on. So we'll start about the mean. We'll talk about the mean, measures of central tendency. First thing is the mean, or we can call it the average. Like, what is the mean? Uh, Guys, the mean is a point estimator for the population parameter. I'm not going to talk really about samples, populations, and guys, may some of you don't want to work with real probability stuff. I will give you the main idea, but sometimes we need to talk about how each idea came. Like, um, when you take a sample, you take it from a population that you want to study it, right? So you take a sample, you get some measures from this sample which can present the measures of the population itself. Like you want to see the average of ages of the city, of your city. Okay, so you may take sample, an appropriate sample for the population size, and can calculate the mean for it, and this mean is unbiased estimator for the population parameter, the mean of the population. You can think about the mean as an it's the expectation. The idea came from the expectation when you guys when you work with random variables and distributions and so on. So the mean is a unbiased estimator for the population mean. You can think of it like what I'm expecting to have the other value. Like for example, I got a sample of 1,000 individuals. Now I'm going to get another one after I have calculated the mean. Like what I'm expecting to get, it's going to be an age at the expected value that I have calculated the mean. You can think of it about the simplest model that you can work with. Yeah, it's a model. It's like a model. It's not really a model, but you can think of it like it's a simple model. It's the simplest model with an error. We will talk about the error uh, later in the next videos when we're going to talk about inferential statistics. You can calculate the mean as you see in this equation. You take the sum of all of your data and divide it by the number of the data, like the sample size n, and you'll get the mean. Like for example, what is the average of ages of these five individuals for 24, 28, so on, 29. You just take the sum of them and we divide it by 5. Sorry, it should be 5. We get 30.8. I think it's really, you see guys, it's really easy to work with, easy to calculate, easy to translate. Like uh, you are a statistician, you are someone who works with data analysis, but you will work with people who don't know nothing about statistics. So you need to uh, get them the results in their spoken language. Like you give them the idea without talking about how do we calculate them or something. Just need to translate it, and I think it's really something easy, but it's not unimportant. It's really important stuff. Now we're going to talk about the median. It is like the mean, and sometimes it is better than the mean. Usually we use the mean when we are working with um, continuous data, like as an example before ages or height or weights. Usually the median, we have some when we have some discrete data, like number um, of customers that enter my market every day or every hour, so on. So these discrete values. The median is the value that is centered in the middle of the data after they are sorted. Uh, there are two equations when n is odd or n is even. Um, you may not get them uh, like why there are two equations, but you will see it here in these examples. For example, what is the median of age of these five individuals